Okay, so next topic which we are going to begin, that is a very important topic from your examination point of view, which is molecular orbital theory. Molecular orbital theory जो है ये हमें exact, it tells us why do atoms combine to form molecules, or if they are combining to form molecules, then how does the overlap of the atomic orbitals take place so as to give us a stable molecule. Before this, there was one theory which was proposed by Sidgwick and Powell, which was known as the VSEPR theory. ठीक है? So VSEPR theory जो था, it explained to us the geometries of all the compounds very successfully with inclusion of hybridization. So hybridization geometries को किस तरह से affect करती है? That was also very well explained on the basis of VSEPR theory. Okay? But it could not explain to us the formation of a coordinate bond. Why does coordinate bond form? Or it did not explain to us the paramagnetic character of oxygen. Although oxygen has even number of electrons, O2 has, we have 8 in one oxygen and 8 in the other oxygen, so we have 16 electrons. Now according to the paramagnetism, what does paramagnetic substances mean? Those substances which are repelled by the magnetic field. Repelled or attracted? Which are attracted by the magnetic field. Diamagnetic are repelled. ठीक है? So paramagnetic, they are going to be attracted by the magnetic field. Attraction will happen only if there are unpaired electrons present. ठीक है? So we say that all molecules which have you can say odd number of electrons, they are going to behave as paramagnetic, and all molecules which have even number of electrons, they are going to behave as diamagnetic. Oxygen has even number of electrons, even then it behaves as what? As a paramagnetic substance, which could not be explained on the basis of VSEPR theory.
What is even and odd number?
Even means, जैसे 2, 4, 6, 8, 10, that is even. Odd means 1, 3, 5, 7 and so on. ठीक है? So that is even and odd number. Okay. Now when we are talking of VSEPR theory, it could not also explain to us the formation of odd electron molecules. Odd electron molecules means that if we have a species like this, H2 positive. Now H2 positive has only one electron. So that is what? That is going to be an odd electron molecule. Formation of odd electron molecule was also not explained on the basis of VSEPR theory. Then the molecular orbital theory was proposed, and it was proposed by two scientists, Hunt and Mulliker. These were the two scientists which explained the molecular orbital theory. Now according to this theory, all the atomic orbitals, they participate to form molecular orbitals, right? So VSEPR theory ने तो क्या बोला था? VSEPR theory के accordingly only the valence orbitals they were participating in bonding. Over here, according to molecular orbital theory, whenever overlapping of orbitals is taking place, the inner orbitals they also get disturbed, right? It is not that the inner orbitals they are not at all affected by the overlapping of orbitals. So molecular orbital theory says even the inner orbital they are going to be affected. In fact, he said that in this case mixing of orbitals of comparable energies, that is going to take place in order to give us molecular orbitals, right? Now according to this theory, number of atomic orbitals overlapping, they will be equal to number of molecular orbitals formed. They are going to be equal to the number of molecular orbitals formed, which means if there are two atomic orbitals combining or overlapping, they are going to give us two molecular orbitals. ठीक है? Then we know that when we are talking of any atomic orbital, it has only one center, isn't it? When we are talking of any atomic orbital will have only one center. Whereas when we are talking of molecular orbitals, we say that molecular orbitals are polycentric. What do we understand by polycentric? That it will have more than one nucleus. So the molecular orbital is represented in this manner. So it is going to be polycentric in nature. Okay? So molecular orbital is what? You can write down. It is defined as, molecular orbital is defined as the region in space comprising the nuclei of the combining atoms around which there is maximum probability of finding the electron. So as you can see over here, it is multinucleated, binucleated in this case. So the probability of finding the electron will be maximum around both the nuclei. Okay? Now, when we are talking of overlapping of molecular orbitals, we discuss one method which is known as LCAO method. LCAO method का मतलब क्या होता है? Linear combination of atomic orbitals. Linear combination of atomic orbitals. ठीक है? Linear combination of atomic orbitals का मतलब हुआ कि if we have this as one s and this as another s orbital, this is how they are going to combine. This is linear combination of atomic orbitals. Okay. Now we say that according to the Schrödinger wave equation which we had discussed in structure of atom, it is said that electron waves, the electrons, they are moving in three-dimensional space, and this space was defined as orbital by Schrödinger. Okay. Now according to this, the electron phase or the electron waves, they have two types of phases. One which is positively charged and the other one which is negatively charged. So every orbital is going to have two charges, one which is the positive charge and the other one which is the negative charge. Okay. Now when waves are combined together, the waves of the electrons, they are combined together, they may combine together in two forms. One, they may combine constructively. ठीक है? Constructively का मतलब क्या हुआ? That addition of waves take place. Right? Addition of the waves that is going to take place. Let's take an example over here. For such cases, the amplitude that doubles. Right? So let's say if this is the wave of one orbital or one electron in one orbital, and similarly this is the wave of the second. Now constructively, if they are merging with each other, let's say the amplitude over here, that is going to be A, and the amplitude over here is also going to be A. So when constructively they are going to overlap, in that case the final wave which we are going to obtain is going to be this, in which the amplitude that becomes equal to 2A. Okay. Now over here you can see that in the first wave, crest is on the first wave which is coming as a crest. In the second one also the first wave is coming as a crest. ठीक है. But when we are going to talk of destructive, the second way of combination is merging is destructive interference of waves. So second हमारे पास क्या आ रहा है? We are getting destructive interference of wave. In this case, subtraction of amplitude is going to take place, or we can say subtraction of waves is taking place over here. ठीक है. So अगर हमारे पास the first wave which we have has the first portion as the crest. Okay. Again, amplitude of this, that is going to be A. And the second wave, the first section is going to be a trough. Right? And the amplitude of this trough, crest and troughs, they have the same amplitude. This is going to be A. Okay. Now the resultant wave over here, that is going to have zero amplitude. This is known as destructive interference of waves. Clear हो गया? Okay. Now when we are talking of constructive interference, so what are we saying? If you remember the wave function which is given as, let me put it here, it is denoted as psi, right? So total psi, if this is wave A, this is wave B, the total psi for constructive is going to be psi A plus psi B. ठीक है. Probability is given by psi square. So psi square, that is going to be equal to psi A plus psi B whole square. Right? So if you are using the algebra over here, psi square should become equal to psi A square plus psi B square plus 2 psi A psi B. Right? So the probability density in case of constructive interference, that is going to increase by a factor of 2 psi A psi B. So probability of finding the electron, that is going to be more over here. Now such molecular orbitals which are formed by constructive interference, they are said to be bonding molecular orbitals. ठीक है? They are said to be bonding molecular orbitals. In case of the second one in which destructive is taking place, what is going to happen over here? Psi, that is psi A minus psi B. Okay, so if you're looking at probability density psi square, that will be equal to psi A minus psi B का square. ठीक है? And therefore we say that psi square, that is going to be equal to psi A square plus psi B square minus 2 psi A psi B. So over here the probability that is going to decrease by a factor of 2 psi A psi B. Right? And such molecular orbitals, they are known as anti-bonding molecular orbitals. Okay, so these are the two types of orbitals which we are going to study. One which is bonding molecular orbitals and the other one that is anti-bonding molecular orbitals. Right? So when we are talking of energies of bonding molecular orbitals and anti-bonding molecular orbitals, we say that the energy of bonding molecular orbitals is always going to be less than the combining atoms. Okay? And the energy of the anti-bonding molecular orbital is always going to be more than the combining atoms. When we will do the energy level diagram, this will become more clear. But as of now, you just need to remember that the energy of the bonding molecular orbitals, that is going to be lower than the atomic orbitals which are combining, and the energy of the anti-bonding molecular orbitals, that is going to be higher than the combining atomic orbitals. ठीक है? Now, bonding molecular orbital is going to be always more stable. Because it is at a lower energy, we know that energy is inversely proportional to stability. So bonding molecular orbitals, they are going to be at a lower energy, hence they are going to be more stable, whereas anti-bonding, they are at a higher energy and hence they are going to be less stable. ठीक है, फिर उसके बाद bonding molecular lowering in energy of the bonding molecular orbital, जितनी भी एनर्जी कम होती है bonding molecular orbital की, that is known as stabilizing or stabilization energy. That is known as stabilization energy. ठीक है? So now we've done 4 things over here. We've done, we know what atomic orbital is. We've already done that. Over here we have discussed molecular orbital. ठीक है? Then we know what is bonding molecular orbital and anti-bonding molecular orbital. Let's just point out the differences between all of these. So let's have a comparison study between both. The first we are going to study the difference between atomic orbital and molecular orbital. The first difference between the two is that atomic orbital, it is going to be, as we just discussed, it is monocentric in nature, whereas molecular orbital, it is going to be polycentric in nature. ठीक है? Then number 2, the atomic molecular orbital is less stable. Okay, whereas the molecular orbital, that is going to be more stable, right? Then number 3, the atomic orbital, they are designated as S, P, D and F. These are the atomic orbitals, whereas in case of molecular orbitals, we are going to talk of sigma bonding molecular orbital and sigma anti-bonding. When we are going to denote anti-bonding, we have to put a star. Okay, so this is sigma bonding, sigma anti-bonding, pi bonding and pi anti-bonding. So these are the differences between atomic and molecular orbitals. Let's go on to the second type, differences between bonding and anti-bonding molecular orbitals. What is the difference between bonding and anti-bonding molecular orbital? ठीक है? First, bonding molecular orbital is formed by linear combination in a constructive manner. That is what we just discussed, that the overlap is taken by constructive overlap of the wave functions. Over here anti-bonding में destructive overlap of the wave functions is taking place. ठीक है? Then number 2, the energy of the bonding is, it has less energy than combining atomic orbitals. Right? Whereas anti-bonding, it is going to have more energy than the combining atomic orbitals. ठीक है? फिर उसके बाद number 3, in case of bonding molecular orbitals, the electron density increases between two nuclei, whereas in this case electron density decreases between the two nuclei. In fact, there is going to be a nodal plane which is present in case of anti-bonding, which we will discuss just now in the next section. So the fourth difference is it has no nodal plane. What is the nodal plane? Nodal plane is the plane where the probability of finding an electron is 0. Okay, that is what a nodal plane is. Whereas in case of anti-bonding, there is a nodal plane present. There is going to be a nodal plane which is present. So these are the differences. Now when we are looking at combination of the atomic orbitals, there are certain rules or factors, you can say, to combine the atomic orbitals into molecular orbitals. What are these features or what are these factors which are required for the combination of atomic orbitals through LCAO method? The first one is that the combining orbitals should be at the same energy or comparable energy. Combining atomic orbitals should have comparable energies. What do we understand by this is, it means that if combination of 2s is taking place, then it can only take place with 2s. 2s cannot combine with 3s. In a similar manner, 1s cannot combine with 2s because there is a lot of energy gap between the two orbitals. Okay? So 1s will combine with 1s and 2s will combine with 2s. Okay? So that is the first factor. The second is the combining orbitals should have proper orientation. What do we understand by proper orientation is that if we have PZ, PZ will only combine with PZ. Okay? And PZ cannot combine with PX. If this is PZ, the orientation is in this manner and the orientation of PX is in this manner, then these both cannot combine. They should have the same orientation. Okay? And number 3, the orbitals should overlap to a maximum extent. Right? The orbitals should overlap to a maximum extent. So these are the 3 features. Then let's go on to the types of molecular orbitals which are formed. Types of molecular orbitals. When we're talking of types of molecular orbitals, it is going to depend upon the type of overlapping which is taking place. Okay? Now we have done 2 types of overlapping which is taking place. One is constructive and the other one is destructive. So let's first discuss the overlapping of s orbitals. S orbitals, you know, they are non-directional in nature. So they will have the positive and the negative charge localized in the same area. Okay? So as a result of which, we can say that if we have the energy increasing in this manner, we have 1s and plus we have another s orbital over here. If there is addition of s orbitals taking place, the molecular orbital which will be formed will be polycentric, having both the nuclei. Okay? Then this is known as sigma s. Okay? Because head-to-head overlapping is going to take place over here. There can't be any sidewise overlapping because of the non-directional nature of s orbital. Okay? And if there is going to be subtraction taking place, The molecular orbital will have this shape, where the dotted line which we have represented, that is going to be the nodal plane. ठीक है? So यहाँ पे क्या होगा? Both the positive charges will come at the same position, whereas over here one will have a positive charge and the other one that is going to have a negative charge. ठीक है? So that is known as what? This is sigma anti-bonding S. Right? So as I just told you कि ये जो बीच में आपको नजर आ रहा है, this is going to be the nodal plane. ठीक है? फिर let's go on to the molecular orbitals from p atomic orbitals. Okay. So in p atomic orbitals, because they are directional in nature, so it shows two types of overlaps. The first one, head-to-head overlap, which is also known as end-to-end overlap. End-to-end overlap is going to take place only in pz, right? So end-to-end overlap में, in case of p, we have positive charge in one lobe and the negative charge in one lobe. If addition is taking place, positive here and negative here, okay, then in that case the kind of overlap which we are going to get this is the molecular orbital which is going to be formed, right? And this is known as what? Bonding molecular orbital. Okay, so this is going to be sigma 2pz, right? Now if subtraction is going to take place over here, subtraction is taking place over here. In this case we are going to have a nodal plane in between. So we have the molecular orbital with a negative charge here, then a nodal plane, negative charge here, and both the positive charges concentrated in the bigger lobe. So this is anti-bonding. So this is going to be sigma anti-bonding 2pz. In case of side-wise overlap, px and py both undergo side-wise overlap. ठीक है? So if we are having the second type of overlap, which is a side-wise overlap. In case of side-wise overlap, if addition is going to take place, this is how we can show the side-wise overlap over here. Okay, so this is going to give us a molecular orbital of this shape with one positive and the other one which is negative. Okay, so this is going to be pi 2px. And if subtraction is going to take place, subtraction of the atomic orbitals, that is going to take place over here, then we are going to get a nodal plane in the center. Okay, so it's kind of a B you can form. We are going to have positive charge and negative charge, positive charge and negative charge. This is going to be the nodal plane, and this is pi anti-bonding 2px. A similar kind of overlap will also take for pi 2py. Okay, so you have to remember that z orbital is going to form sigma and px and py, they are going to form pi. Right? So we are only left with the last topic in this chapter, which is the energy level diagrams and filling up of molecular orbitals. Okay?